Oh, hi. Good evening. Yeah, I dressed up because I made a new routine nowadays. During the weekend, I go out. Yeah, I go out during the weekend. Saturday evening, then dress up like this and go out and go to a restaurant slash bar in my neighborhood, somewhere around here, because that's my political campaign. Okay, because I need to be seen. Okay, I'm running for Alaska State Senate for this neighborhood, so yeah, it kind of pretext, just to get out there and watch people and yeah, and then yeah, okay. So humanology, huh? Okay, yeah, we can do that. Uh, let's see. Um, we are doing very basic. Okay, the kind of like a dot product. Okay, so that's what we do here. Okay, so we gave some weight, right? But let me explain some little more about the weight assignment. Okay, so previously, basically, the you have this criteria, right? And we assign weight. So if I'm employer, my number one criteria it would be your ethics, your morality. Okay. Second criteria would be your knowledge, your skill set. Third criteria would be uh, like your looks and feels. Okay. Do you look presentable? Are you fashionable? That kind of stuff. Okay. Do you smell nice? That kind of stuff. Okay. So now, uh, so we assign weight, right? But there's some other ways to assign weight. Let's say, so morality, and you have uh, knowledge, and you have beauty. Okay. So, um, out of 0 to 10, how important it is for you that this person is moral and ethical person. Okay. For me, from out of 0 to 10, so that's pure scholar, right? Yeah, I give 10. Okay, so important. Knowledge, I give it 9. Beauty, I give it 8. Okay, now We need to normalize this, okay, such that if we sum them up, it becomes 1. Okay, so how do you normalize that? Yeah, you just add them up. 17, 27, right? And you divide. Okay, that's how you normalize it. Okay, yeah. Then if you add them up, yeah, that becomes 27 over 27, which is 1, right? Yeah. And in terms of scoring, is scoring the your weight vector and score vector, right? So score vector is ranges from -10 to +10. Okay, so if this person is very immoral, the worst immoral person, then we also have -10 here. Okay, and knowledge out of -10 to +10, whatever. Okay, beauty again -10 to +10. Okay, now so that's labor market. Okay, job market, labor market. Okay, so uh, labor market is like this. All right, so you have some lucrative position, like let's say in Google or Microsoft or Amazon, very high paying job, right? Probably they get their job candidates from like Ivy League school or Stanford, Berkeley, or Harvard, Yale, right? Most likely, right? Because those high paying job, that's high value product, so it's expensive to purchase. Job as a product that you purchase. So how do you purchase this 6-digit figure job? You pay with your diligence because it's not easy to go to Harvard, Yale. Competition is very high, right? To Stanford, right? To get admitted into big schools is very difficult, and you have to study a lot. So that's the price that you pay. You pay with your time, pain and suffering, effort, okay, to get into the top schools. And then now that's your currency in the job market, okay, your degree. And you purchase a job with that currency, your degree. Okay? So it's exchange, okay? So, yeah. So that's job market, and we have to talk about romance market too, okay? So we are combining mathematics, economics, humanology, everything, right? So that's the dot product concept, and so weight vector, score vector, that's the evaluation. Okay, that's why we use E for evaluation. Okay, it's kind of like energy. Okay, so yeah. Okay. So what do you mean by negative value in knowledge criteria? Well, for morality, for beauty, yeah, we can kind of figure it out, right? 0 means probably about average. Plus 10, very beautiful and very moral, by far more than average people. Minus 10, very immoral. Minus 10, very not aesthetically pleasing. All right, so uh, but in terms of knowledge, yeah, we can put assign 0 as the average knowledge of this person. Plus 10, minus 10, below average, more than average. Okay? Uh, so that's evaluation, all right? Or we can call it value, whatever. Okay? Very good. Okay? Uh, romance setting, I'm kind of hesitating whether we should do that or not because I don't want to be offensive. Okay, so it's pretty much the same like this. Okay, you have set of criteria, right? And then priority, right? Weight vector and score vector. You do the inner product. That's you the evaluation in romance market. Okay, no matter what criteria you use. Okay. So yeah, let's do romance market after a break, but we'll be very careful in order to not to offend anyone. How about that? Deal? Okay. Yeah, we can do it without offending anybody. I think we can. It'll be a little bit challenging though. Okay, we can do it. We'll take 5 minutes break. Okay, so and we'll do it. Okay. Okay. Yeah. Okay. Ah. Okay. We're back. So we'll not be judgmental. Okay. We're not going to be judgmental about it. We can do it, right? So let's say you are a lady, okay, and then you go to online dating site and so there are suitors, courtship behavior, right? And so again, I don't know anything about women, all right? So But let's just imagine, okay, how it might look like hypothetically. Okay, so uh, from my experience, okay, yeah, I've been to online dating sites before. Well, first of all, let's say you're a lady, okay, you want somebody local, right? Right. So that's important. So, by the way, humanological memory distance, that's memory time distance, that's pure scalar. Okay, there's no such thing as negative distance. Okay, but at the same time, it's a vector from A to B and B to A. Okay, they're not the same, right? So it's non-negative vector. Okay, so yeah, strange, strange concept, but that's just the way it is. It is tricky concept. Okay, so anyway, so now, so you're a lady, and you probably want something in common with. Probably you want a guy who that you have something in common with, like similar hobby, like hiking, right? Or if you're into fishing, I don't do fish anymore. I used to fish, but nowadays I don't. Okay. Yeah, I just run. I keep things simple. Okay. Okay. So, and if you're a lady, if you run, you like going to you like hiking, running. Then probably you want to find somebody who is also a guy who also hike, run, right? So that you do those things together. Okay. And if you're a dancer, you probably want to find somebody who also dances too. Okay. If you like karaoke as a lady, you probably want somebody, some guy who also like karaoke, right? So those commonality, it means uh, these two people are very similar. Meaning, the ideological distance is very small. That's different from the memory time distance. Okay? Memory time distance is like, let's say you go to work or you go to school and you see the same people all the time, whether or not you like them or not, if they are like you or they are very different from you, it doesn't matter, right? But you get to see them every day. So then memory time distance is very small because their image, their voice register in your memory, your perception memory, random access memory. Okay. Okay. So, but ideological distance, it's like that. So running, okay, any behaviorism, that's what we mean by ideology, ismology. Okay, so like running ism, hiking, pro run ism, pro hiking ism. Okay, that's behaviorism, activity. Okay, and if you run, then you belong to this ideological group of runism, pro runism. Okay, so that's what we mean by ideology. Any activity. Okay, so uh, yeah. Now, uh, so ideological distance is this. Okay, so let's define ideological distance mathematically. Um, let's say Adam is out of 10 to minus 10, highly runist. He's a runner, okay? And when it comes to dancing, fairly highly pro dancist, okay? And let's say so he run and he dances, okay? Let's say um, trying to think of name. Mary, okay? Mary is anti-runist. She doesn't like running and she doesn't like dancing, okay? Now, what's the ideological distance between these two people? Uh, Ideological distance is symmetric. So ideological distance from Mary to Adam is ideological distance, okay? We call it delta, okay? Ideological distance delta is kind of commutative, okay? Like ordering doesn't matter. But the memory distance is not equal to it's not commutative, okay? It's not symmetric. Okay? Yeah. Right? Memory time distance, okay? So but ideological distance, they are symmetric, okay? They are commutative, okay? So it's here 10 minus 10 plus 9 minus 7, okay? Which is equal to this 20, 16, 36. Okay? Maximum distance is like 40, right? Okay, good. Like 20 here, 20 here, okay, so to define that, ideology, right? So we call it ideological score, okay? Yeah, pro-run, anti-run, okay? Um, so ideological scoring, okay. We'll just call it AI, okay? So your horizontal juxtaposition, I from 1 to n, AI. Here, horizontal juxtaposition, I from 1 to n, mi. Okay? Now, the distance from Mary to Adam is same as distance from Adam to Mary because we're going to define it like this, okay? Sigma I from 1 to n, absolute value of AI minus mi. Okay? So this is commutative, right? Because we put absolute value around. Okay? That's why the distance is ideological distance is commutative because of this. Something a minus b absolute value is same as b minus a absolute value is commutative. Okay, that's the definition. Ideological distance. Very good, very good. Yeah, we're getting somewhere. All right, so yeah. Hmm. So if these two people are very similar, distance is very small. Ideological distance. Okay. Now we can make some connection between ideological distance and memory time distance. Okay. They're not the same, but there's some relationship we can find between ideological distance and memory time distance. Okay. Let's think about that relationship. Okay, so we're gonna take 5 minutes break and then we grab whiteboard, another whiteboard, and then we explore that possibility. Okay. Very good. Very good. And yes, we'll do romance market. Okay, so you know, in romance market, yeah, physical distance matters, right? You want somebody close by, right? If you're an online dating site, yeah, you want somebody close by, same town, right? At least same state, right? So yeah, the proximity, physical distance, it does matter, and also ideological distance matter, and which will lead to shortening of memory time distance. Okay. Okay, we'll take 5 minutes break. Okay, so. All right. Yeah, I love neighborhood dogs. They're so cute. They bark at me, right? I'm like, I love you too. That's so cute. Yeah, they just want to play with me. That's all. Yeah, I love dogs. It's just that I don't want to have them because then I have to feed them, clean after them. Oh no. I think I should write this down. Okay, so. It's chilly. Easy mathematics, right? Yeah, humanology, mathematics in humanology is just like this. It's very basic, very basic. Okay, really super duper easy. Okay, so that's how it typically it is. In humanology, the mathematics very easy. Okay, so uh, let me take a picture of this. Okay. Okay. Then we'll find a whiteboard to erase and then go from there. Okay? Alright. Yeah, we are done with this cyclic sequence, so we can erase all this safely because we are done with it, okay? And it was a success. We found old school formula, which is really big, right? And then we found brand new, easier formula using expansion in mathematics. We expanded, we improved mathematical language by adding this, what, Boolean hybrid, okay? So, also known as Iverson bracket, which they say is generalization of Kronecker delta. Sure, whatever. We rather call it Boolean hybrid instead. Right. Okay. So let me clean my glasses real quick. It's too cloudy. Better. Much better. Okay. Let's see. So what did I order in the restaurant? Steak, ribeye. I didn't eat it though. I just brought it home. What I ate, French fries and salad, and it was fantastic. Very very good food. I love that cabbage. Oh, have you ever had cabbage wedge? Wedge cabbage? Oh my goodness, so good. So fresh. I love vegetables. Oh my goodness. I'm vegetable lover, okay, so okay. So memory distance, if you remember, emotion equation is equal to view vector, right? Dot product by over memory distance. Okay. Now, from A to B. Okay? And so, if two people are agreeing, let's say, yeah, the so view vector, that's basically ideological vector. Okay, so are you runner, pro run, anti run? Are you pro dance, anti dance? Okay, yeah, or are you pro this, pro that? Are you more conservative or more liberal? Whatever, right? So let's say you are a woman, okay, and you go to the dating site, all right, and there are a lot of suitors, okay, and also you read their profiles, look at their pictures, online profiles, pictures, and whatnot, right? And then, uh, and also, yeah, some other considerations like how much money he's making, right? So if you're a woman, you probably want a guy who make at least same money as you do, right? And hobbies like, is he athletic like I am? Is he athletic like I am? I'm a runner, I'm a dancer. Is he athletic like I am? That kind of stuff, okay? Yeah, kind of like body type, okay? But yeah, we're talking in terms of athletics, okay? So pro run, pro dance, pro sing, okay? Hobbies, and yeah, common interest, right? So, and if you find that guy and when he messaged you and you replied and you start chatting online, okay, and then you realize this guy is very similar to you, okay, make about same money and common hobbies, and then you start talking about politics and religion, okay, and very similar religion, similar politics, right? Yeah, so you like him as a woman, okay, and he likes you, so you decide to go out. Why? It's in order to maximize this positive emotion, okay. So uh, here we did the view vector, we did the dot product, okay. So and the ideological distance from A to B is sigma uh, VA minus VB absolute value, okay. Okay, so uh, if ideological distance is very small, it means they are very similar people, two people, okay. uh, let's say Adam and Brianna, okay. Brianna, that not name exists. It's kind of English name, okay. It's like Brian, female version of Brian is Brianna, okay. So okay. So if they're very similar people, they're both single, and then and let's assume that they're same race, okay, and then they're single, similar age, similar interest, similar level of salary, okay, and also the distance between the physical distance between them is very close, same town, okay, another commonality, okay. So they like each other, okay, because they're very similar to each other, okay. So uh, they agree, they're both anti-gun and they're both pro-choice, they're both liberals, okay. So yeah, they like each other, okay. So positive emotion, right? That's why they want to meet, in order to decrease the memory time distance, because uh, distance memory time distance is equal to 1 over time they spend together, okay. In order to maximize this positive emotion, their happiness, they want to decrease the distance, meaning, so time is 1 over distance, right? Yeah, time is amplifying factor, okay. What is this time, AB? Time that Adam spent thinking about Brianna, which is not the same as time that Brianna spent thinking about Adam. So what Adam wants, because Adam really likes Brianna, he asks her out in order to maximize the positive emotion, happiness. He want to spend a lot of time, and by shortening the distance, okay, in order to maximize the positive emotion, okay. Yeah, so distance time is inversely proportional. So that's, it makes sense, right? Yeah, that's the magic of humanology. Okay. Yeah. Excuse me. If you recall, memory time, it looks like this, right? This memory, okay. Okay, so okay, so time that Adam thinking about Brianna is sigma integral uh, e to the teeth dt, right? You're adding up all the time in the past that Adam spent thinking about Brianna, or seeing her, calling her, talking to her. Anytime that Brianna's image registers in Adam's memory, so that's memory time. Okay, and but we have to do e to the teeth because it's memory degradation. Okay, so that's what this is. Okay, so okay, yeah. I'm just reviewing in case you forgot. Alright, so it's about time to take a break. Okay, so we'll take a break. Alright, so very good, very good. We'll talk more about this. Okay, because there's some more to it. Alright, Yeah, what's the relationship between ideological distance and memory time distance? We haven't answered that yet. We kind of did, okay, but yeah, we keep thinking about this, okay? Okay. Whew. Okay. So, having fun. Told you we're gonna have some serious fun, right? I'm having a lot of fun here, okay? I hope you are having fun too. Okay, so yeah, this is good stuff, really. High quality, okay? Welcome to humanology again, alright? It's very, very cool stuff, okay? So I'm very happy to share it with you, okay? Um, so, yeah, let's say these two people, okay? They're very happy because they're so similar to very small distance, right? Ideologically small distance, okay? And guess what happens? Then these two people, Adam and Brianna, they may even get married, increasing memory time, decreasing memory distance. So, the short distance, ideological distance, leads to short memory distance. That's the relationship. They're kind of the same. I mean, this ideological distance uh, memory distance follows ideological distance. Right? If two people are ideologically too different, then there will be less and more memory distance. Because you don't want to deal with that person in order to decrease the pain. Okay? See what I'm saying? That's the relationship. Okay? Yeah, you rather spend less and less time with them, right? Yeah. Okay? So, enough with the romance market. Okay, so now, uh, there are a lot to talk about romance market, and I did so in the 200 Lost episode. So we'll talk about it later. But we gave enough love to romance market. Now let's talk about ismology. All right, sounds almost like osmosis, right? Ismology, it's about study of ideologies. Okay, and what's the relationship between ismology and this emotionology? I guess we can name this, right? Emotionology. Or yeah, yeah. I mean, you have view vector here. That's the set of ideologies in you. You're pro-gun, anti-gun, or you're pro-abortion, anti-abortion, and blah blah blah. List of issues. You're pro-run, anti-run, pro-diet, anti-diet, whatever, right? So, uh, but uh, how the ideology spreads is because peer pressure. That's one example. Okay, like for example, tattoos and piercings nowadays it's quite common, right? But it was not like that about 20 years ago. Okay, uh, long time ago in America, only gang members, mostly like Latin America related gang members, yeah, they did a lot of tattoos. Nowadays, it became mainstream, right? And I don't like that trend, to be honest with you. Okay, but so why does an ideology spread like tattooism? Okay, because of this. Okay, so let's say it's kind of like peer pressure. Okay, so let's say I go to school and I'm the only one who don't have any tattoos, for example. Okay, and then whenever I see people in my class, I'm kind of left out, you know. So this difference between me and other people, so that caused me some pain. Okay, so I'm tattooist, and everybody else is pro tattooist. So there's this negative emotion, minus times plus. Okay, so in order to minimize that kind of pain, I decided to have tattoos to be like others, in order to minimize that pain of being different. Okay, so that's how ideology spread. Okay, it's about minimization of pain and maximization of pleasure, agreement, belonging, right? But I'm not gonna have tattoos because I don't like it. Okay, I'm not saying it's bad or right, good or bad. I'm saying I don't like it, so I'm not gonna have tattoos. Okay, so okay, Now, is it fair to say? Now, we pretty much cover every basic, right? So, yeah, good, good. Humanology is easy, okay? It's very easy, okay? So, it's no brainer, really. Yeah, it's easy. Uh, do you want me to talk about Einstein's relativity disproof? Yeah, let's do that because we spent enough time for humanology. Okay, we gave humanology enough love, so let's leave this and I'll share with you the disproof of special and general relativity by Mr. Einstein. Okay, because I don't like postponement, delay. I don't like waiting, so I teased you. I have teased you enough. Okay, so let's just go ahead and do it. Okay, because it's not that difficult. Disproving something is a lot easier than proving something. You just need one counterexample. Then, okay, let's take 5 minutes break. Okay, so then we'll do Einstein. Okay, anti-Einstein. Okay, I hope you like it. Okay. Yeah, we'll take 5 minutes break. Okay, so. So are you ready for this? Ready or not, here we come. Okay. Uh, all right. we're gonna come and get you, Mr. Einstein. Yeah, let's go get him. Okay. You ready? Ready or not, here we come. Okay, so by the way, I could be wrong. Okay, and Mr. Einstein, he could be right. Okay, so I'm only human. All right, so I don't know. Okay, so but I have reasonable doubt about his theory. Okay, as far as I know, his theory is just wrong. Okay, E equal mc squared. I don't think that's correct equation. Okay, I don't think so. The general relativity of field equation, I don't think that's correct at all. Okay, because it's based on very, as far as I can tell, it's based on very wrong assumption. Okay, so so the history goes like this. Okay, so they try to measure the relative speed of light. Okay, and they fail to measure it. Okay. So what? So Mr. Einstein assumed that speed of light is absolute. Okay. He just assumed those he relied on those experimental results where the relative speed of light is same. Okay. So I don't know where to begin. So in order to fix the speed of light, okay, he had to change the time, like time slowing down, time dilation. Okay, to keep the speed of light, relative speed of light as a constant. Okay, then something has to give, right? And he picked time and space. Okay, time. Just time dilation concept. Okay. So I don't even know where to begin, dude. So Mr. Einstein, he says, let's say there are two people, okay? A and B. Okay? Now, there are three people, okay? And their clock, okay, A, B, C, D, four people's clock is perfectly synchronized. How do you do that? Well, let's assume, for the sake of argument, okay? Let's just go along with Einsteinian logic, okay? Let's say there is time dilation, okay? Let's assume that. So, this is proof by contradiction and also proof by counterexample combined, all right? Let's assume Mr. Einstein is correct, okay? So, and it will lead to some contradiction later on down the road, okay? So, okay, Mr. Einstein, let's assume you're right, and then let's say time slows down as we move around, time dilation. All right. So then, how do you synchronize the clock? Okay. In the beginning, BCA, they are all together in this spot. Okay. BCAD, ABCD, they are all here, and they synchronize their clocks. Okay. And then because we assume that as we have some speed as we move around, there's time dilation, right? So if C stays here and B and D and B, D, A, they go to their respective positions, now their clocks are no longer synchronized anymore because C is not going anywhere. B's go there, D go here, A go there. So now their clock is slower. When C's clock only 1 second passed, B, D, A, because they had some speed to go to their places, now it's only like 0.7 seconds instead of 1 second with this time dilation. Okay? So in order to prevent that kind of asynchrony, we want to maintain the synchrony, okay, synchronousness, right? Let's say when B go there and D go there, C just move in a circle with the same speed like B and D and A, right? So yeah, C just walk around and come back until B, D, A, they go to their position, okay? What, D, A takes longer to go over there? Yeah, then B walk around, circle around, okay? With the exact same speed. So in order to preserve the synchronousness of the clocks. Okay? Yeah. So A, B, C, D, they all move with the same speed, okay, in order to preserve the synchrony of their clocks. Okay, C just circle around, okay? Yeah. Now, so their clocks are perfectly synchronized, okay? Now, B, C, D, they don't move. Only A moves. This way. Okay? Some constant speed. Okay? B, C, D, they don't move. Okay? Now, because of time dilation, A's clock will be off. It will go slowly. A's time will go slow. When B, C, D, their time is perfectly synchronized. Okay? Now, but A's time is off. When B, C, D experience 1 second, A experience 0.7 second passed. Okay? So, when 1 second passed by, so here is A prime. So A come from here to here, all right? 0.7 second passed by. And A stopped. And they are comparing the clocks because their clocks are very big. Okay? Yeah. It's kind of like stopwatch. Okay? So BCD, they say what it's been only 1 second, and it has been 1 second passed by uh, when A moved from here to here, position 1 to position 3, okay? But in A's clock, after A stopped, it says 0.7 second, not 1 second, okay? Assuming time dilation by Mr. Einstein, okay? Now, so A is in a car, all right? Okay. Now, the next scenario is this. A is not moving, but B, C, D is moving on a train. So B and C and D, they are in a train all together. Same distance, okay? Now, they start to move this way when A is not moving. Now, let's see what happens, okay? Why don't you think about that? Okay? That's basically the proof or disproof. Okay? Why don't you think about that? What happens? A is not moving. It's the scenario number 2. A is not moving. B, C, D, train, they are moving all together that way. Okay? So, and see what happens. Okay? And it's the same velocity, okay? Opposite direction, but same length. 1 meter per second, whatever, right? So yeah, we'll take a break, okay? And we'll do with the scenario number 2, okay? You got to disprove? Not yet? Okay. I mean, it's easy, right? Yeah, there's my brown pen. I want to have green pen. Yeah, this brown pen is fine. Okay. So, in that case, second scenario, 1 second passed by, and now D is here, now B, C, D, because it's moving train, okay? Going that way. And A is static, alright? When 1 second passed by, 0.7 second passed by in their time, assuming time dilation, okay? And that's the contradiction right there. Why is it a contradiction? Let's think about it. It's this, all right? In the universe, all right, there's no such a thing as an absolutely static observer, okay? In the universe, in space out there, okay, speed is relative. There's no such a thing as absolutely static observer, and there's no such a thing as absolute speed. Everything is relative, okay? Out in the space, let's say there are two rockets, okay, and they go like this or like this, okay? Out there in the space, let's say there are no stars, no suns, there are just two rockets, okay? And one rocket is like this, the other rocket is like that. You cannot tell because there's no such a thing as absolutely static frame of reference that doesn't exist, okay? So if rocket is like one, rocket A is this, rocket 2, rocket 1, rocket 2, okay? If it goes like that, there's, you cannot tell whether this rocket 1 is static and this rocket have some 1 meter per second, or this rocket 2 is static and this rocket 1 is going backward by 1 meter per second, right? So speed is always relative, okay? There's no such a thing as an absolutely static observer. That's a fiction, okay? Speed can only be defined as relativity in relation to another rocket, another person, right? Okay? Because this, and let's say there's only one rocket, then you cannot tell whether this rocket is static or moving through some constant velocity. Why? Because you cannot define a velocity when there's only one entity in the universe. So speed 0 and constant speed like 1 meter per second is exactly the same thing. Okay? Unless this guy is accelerating, then yeah, you pull back, yeah, this inertia, right? Okay? So, there is no difference in the universe when BCD is not moving but A is moving that way with 1 meter per second, or A is static and BCD is moving that way with 1 meter per second, okay? But it results in two different time. That's the contradiction, because 0.7 is not equal to 1. All right. So that's the disproof. That's the proof that special relativity is wrong. It just doesn't work. You get it? Easy, isn't it? I mean, people may say, physicists who spend their lifetime studying Einsteinian relativity theory, they may say, "Oh, you don't understand. You don't understand. That's naivete. You don't understand Einstein's theory. That's why, yeah, this is all. Yeah, you got it wrong. Okay." Most likely, that's what they're gonna say. But well, they're entitled to their opinion. Okay, but this is contradiction. Okay, so this is the proof, right? Simple, isn't it? Yeah. I'm sorry, Mr. Einstein, but I do what I gotta do. Okay. So E equal mc squared is the wrong equation. Okay, it's based on that faulty assumption. Okay, so how about the speed of light? Is that constant? I don't think so. I don't think there's anything special about speed of light. Okay, if I am going very fast, the relative speed of light will be less than 3.8, 3 times 10 to the 8 meter per second. It will be less than that. If I'm going at the half of speed of light, then the speed of light, that photon, will be half of the c. Okay, the light shouldn't be given any special treatment. Okay, so speed of light should not be regarded as some law in physics, because that's what Mr. Einstein assumed, and that's a wrong assumption. Okay, so yeah, I guess they failed to measure the relative speed of light because speed of light is too fast. It's too big a number. Okay, so it's very difficult to experimentally determine that. Okay, so like margin of error or whatnot, right? Okay, so we're done with this proof of special relativity. It's that simple. Okay, that's why I was able to do so, because my physics, my mathematics is not that good. Okay, very shallow, very short. All right. Okay. Yeah. Easy as A, B, C, D. Okay, and actually we don't need C. Okay, we don't need this middle guy. Not really. Right? We just need B and D. Okay. And there's this Einstein Poincaré synchronization method. We don't need that. Okay. Yeah, just promenade, just walk around with same speed until A get over here, B, D get their places. Okay. Yeah. No brainer, right? Yeah. Yeah. What? Are you not satisfied? Is it too simple? It is. Is it not good news? I mean, if you don't buy this, that's, I wouldn't say that's your problem. I would say it's your freedom. Okay. What can I tell you? All right. Yeah. You accept this or you accept Einstein's theory. That's your freedom, and I respect that. Okay. But as far as I can tell, yeah, Mr. Einstein was wrong. I'm sorry. Did I disappoint you? Is he your hero? He used to be my hero too. Okay? Yeah, but I'm sorry. Yeah, he was wrong. Okay, as far as I can tell. Okay, because one is not equal to 0.7. All right, and it should not depend on the direction of movement. A moving that way and B C D moving that way. It should not depend on that. All right, but if we assume time dilation, we it results in this contradiction. One is equal to 0.7, and they are not. That's why this time dilation theory is wrong. Okay, there's no such a thing as time dilation or length contraction. E equal mc squared. There's no such a thing. Okay, it's all wrong. Okay, how about this nuclear physicists measuring this mass loss of mass? I guess that they made some mistakes there. Okay, I just don't buy it. Okay, there's no such a thing as mass energy equivalence. Okay, it's all fiction. It's politics. Okay, they just wanna belong to the mainstream. They're scared. Okay, so they fudge the numbers to fit into this Einsteinian framework. Okay, but there's no such a thing as E equal mc squared. That's a wrong equation. Okay, so everything in special relativity is wrong. Everything. Now we take 5 minutes break, and we will go after general relativity. Okay, and that's also very simple disproof. Okay. We're having some fun, right? Good. Uh, yeah, let's grab another whiteboard, okay? So let me take a picture of this, okay? So Yeah. Yeah, QED, okay? Because 1 is not equal to 0.7. It's that simple. Because the in the universe, okay, there's no such a thing as steady observer. Okay, it's a fiction. All right. Velocity can be only defined in terms of relative velocity in relation to another entity. Okay. So that's how we prove this. Okay. So, all right. Uh, we use this guy. Okay. All right. Let me tidy up this place. This all this gunk. All right. How about all these physicists? How can it be possible that all these physicists, scientists, they were wrong, except for me? Is that possible? All these millions of physicists for 100 years. Is it possible that they were all wrong? The professional physics, professional scientists, and I'm the only one who's right. Is that possible? I understand that's very difficult to believe, but science is not religion, okay? It's either you're right or you're wrong, okay? And can all those people be wrong? Yeah. Why? Because scientific community is also very political. It's about ideological battle. Okay, so case in point, general relativity. Okay, so Mr. Einstein he predicted that in this solar eclipse you will get to see stars behind the sun. Okay, so that is sun, and that planet Earth, and solar eclipse. Okay, there's moon somewhere here, whatever, right? But the bottom line is, if there's star behind the sun, Einstein said you will be able to see this because light bend due to the gravitation of the sun. So even if the star is behind the sun, you should be able to see it. So that was Mr. Einstein's prediction. And astrophysicists, astronomists, they analyzed data, and they said, I'm sorry, Mr. Einstein. Yeah, we didn't see any this warping, bending of light. I'm sorry. That's what they found at first. But Mr. Einstein, he started to gain this popularity in magazines and newspapers and television, and he started to gain this celebrity status and his stardom, star power. Oh, Mr. Einstein, the great, right? So he started to gain some political influence. So next experiment, they said, yeah, okay, maybe we'll force some data, and then yeah, we'll just say he's right. Yeah, there's some warping of light bending over the gravity. Yeah. We'll just give it to you. Okay, I think that's what happened. Okay. Just fought some data and yeah, you're right. You're the star, Mr. the Great, uh, Mr. Einstein the Great, right? I think that's what happened. All right, this is going along with this big giant. Okay, uh, we are like it's like David versus Goliath kind of situation. Okay, I mean we are not engaging any physical battle, but it's a metaphysical battle. All right, yeah. Okay, yeah. I mean, we are not engaging any physical battle. We are doing metaphysical battle. Okay, so that's how we do it in humanology. Okay, so we're very peaceful people. We are gentle. There's this band called The Gentle People. I love that band. Okay, very techno kind of great sound engineering. Huge fan. Shopping World. I love that song. I think the band members came from Australia, Europe, okay. But I think the group, the band itself, I think they are American, okay. Because yeah, Australian America, and some European Americans, okay. So yeah, the gentle people, okay. They are very popular in Japan, of all places, but not very well known in America, though they are American band. Okay, so why is this wrong? It's because of this. So, Mr. Einstein, he made this assumption that I think is false and unfounded, groundless. Okay, uh, the way Mr. Einstein thought is this. Okay, so let's say you are in an elevator, okay, or rocket. It has some acceleration, a, okay, vector. Then you feel inertial force, okay, just like car. In your car, as your car accelerates, your body pulls back, right? As if somebody's pulling back. Somebody's pushing you back or pulling back, like 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 this. Okay. So yeah, as your car accelerates, your body pulls back. That's the inertial force, inertial mass, whatever, right? So Mr. Einstein he assumed that okay, so inertial force. Let's say you have this scale, okay. So before we accelerate this rocket, okay, you have this astronaut, okay, and you have this scale. How much do you weigh? You weight, okay. In space, what's the reading of your weight in the scale? I give you a minute. Okay. Ignore all the gravitational effect of this rocket body, alright? Because gravitation is very small force, okay? Very weak force. So, okay? What's the scale reading in space? There's no planet around, there's no acceleration, it's just floating in the space, okay? What's the reading? Zero, right? Yeah. But if this rocket is landed on Earth, on a launch pad, then yeah, due to gravitation, now you have this gravitational mass, your weight. Okay? Yeah, F is equal to mg, right? So that's your weight. G, gravitational acceleration, okay? F equal ma, right? Yeah. But if this rocket, there's no other planets, it's already in space, so this rocket accelerates with g 9.8 meter per second squared, right? Acceleration. Okay? Then the weight scale will be the same as on the surface of the Earth, where the rocket is just landed in this launch pad without any acceleration. But so Mr. Einstein said, assume that the this accelerative mass, the weight this guy feels when this rocket accelerates in the space, is the same as gravitational pulling. Okay, so inertial mass and gravitational mass, they're equivalent. That's what he said. Okay, that's what he assumed. Okay. Now, so Mr. Einstein said, how about light? Okay, first of all, you got this, right? So I'm going to erase it, right? If this rocket is moving in a constant speed, okay, the trajectory of photon, constant speed v, okay, the 1 meter per second, whatever, okay, the trajectory of light, so photon go this way, okay, so trajectory of light will be like this, okay. Yeah. Why? Because this rocket is going up, right? It's exactly the same as everything is going down. So light goes that way, and also it's going down. So vector summation goes like this. Photon going this way. I mean, if this rocket is not moving and light comes in, the trajectory of this photon inside of this rocket window, this rocket has window, right? Yeah, it'll just go like this, but if rocket is moving up, then the trajectory of light will be like this. Okay? We take 5 minutes break, alright? So I need some vocal rest. So. Okay? Now, my question to you, what if this rocket is accelerating? Then what will be the trajectory of light inside of this rocket? Okay? Yeah. 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 Answer that if you want to, okay? Okay. Yeah, I just washed my face, to refresh. It feels so fresh. I love this Alaskan, cold Alaskan water, tap water. I love Alaskan water. Okay. So, this is my earthy brown glasses. We are doing gravitation, okay. So what's the light trajectory when this rocket accelerates? It's constant acceleration, okay? So now it's not constant speed, but constant acceleration A, okay? So the trajectory becomes, yeah, parabolic, right? Just like on Earth, you throw the ball parabolic path, right? Yeah, y is equal to minus x squared, kind of, right? So Mr. Einstein, his theory is this. Okay, so yeah, so there's no difference between gravitational force, gravitational acceleration g, and this rocket moving with constant acceleration g. Okay, so yeah, there's Earth or Sun. Yeah, light will photon will bend like this, just like we are throwing a ball on Earth. Yeah. So that's his theory. Okay? In a nutshell. Do you see anything wrong with that? Do you buy that theory? If you ask me, I don't. Okay, I used to, but not anymore. Okay? And I'll tell you why. Okay, so Mr. Einstein, he was not satisfied with general relativity theory, so he tried to come up with a unified field theory, and that failed. Okay, so like electromagnetic field would light bend in electromagnetic field, just like it would bend parabolic fashion in this accelerating rocket in space, and or because if light bend like this in a parabolic fashion, accelerating rocket, he said it should also bend around the gravitation. Okay, okay. Okay, how about electromagnetic field? Okay, would light bend? Let's say you have electromagnetic field. Okay, you have some capacitor, whatever. Okay, I don't like this black pen, it's wearing out, so we use blue for electromagnetic field, electric field. Okay, electric field. Yeah, if there is some positive, positively charged ion or electrostatic, positively charged whatever. Okay, yeah, you go that way because that's the direction of electric field. Plus plus repulse, plus minus attract, right? Yeah, that's electric field, right? Now, it's kind of like gravitation, right? Gravitation field, force field, vector field, right? Yeah. What happens when light photon p pass through? Does it go up or does it go down? Know this: photon does not have any mass, and it's not electrically charged. Photon is a model. Okay, it's yeah, electromagnetism. Okay, photon is like it's a hypothetical particle. It's just for convenience sake, but because light has wave property, and at the same time it has particle property too, like quantum. Okay, unit. Okay, yeah. But it's electromagnetically neutral. It's neither positively charged nor negatively charged, and it does not have any mass. That's photon. Okay, so what happens here? Hmm? It's force field. So should it bend downward or upward? Huh? It shouldn't, right? How about magnetic field? You have North Pole, South Pole. Where does the light go? Hmm? It's go upward, downward, like parabolic fashion. What? Do you see where what I'm getting at? Huh? Mr. Einstein, Mr. Einstein. Okay, how about this? Wind. Westerly, easterly, northern wind, Arctic wind, okay? Wind. A couple of days ago, I went out to frozen lake to run, and there was Arctic wind, so it was pushing me. I ran against the wind. That way, wind was blowing to my face, like because I was like resisting. So it gave me extra workout for my legs to go against the wind on a frozen lake in Alaska. Arctic wind is very strong wind. About for 7 minutes, I guess, and then I was coming back to my parking lot to my car, and now wind is pushing my back. So I thought I could fly even. Okay, so I told that to my friends. Okay, and they said, "Hey, you should have spread your jacket like that and see what happens." Like, oh, I was like, why didn't I think of that? So next time when there's Arctic wind on the frozen lake, yeah, I'll try that and see what happens. Who knows? Maybe I can fly away like a kite. Just kidding. Okay, this wind force, yeah, it's like molecules, air molecules, pushing my back or pushing my front, right? Wind force. What happens when photon pass through? Would it bend? Would it bend? Would this photon bend in a parabolic trajectory? Can you blow light away with wind? Would it go like this, parabolic fashion? Huh? Think about it. Okay, we'll take 5 minutes break. Okay, so Gravitation, there's nothing special about gravitational force. Gravitation should not get any special treatment. Just like light in special relativity should not get any special treatment. Speed of light, no. Not in science. We are not doing religion or politics. Nothing gets special treatment. Gravitational force or light. We are not dealing with religion or politics, okay? They should not get any special treatment. Okay? Because physics is science, at least supposed to be. Not politics, not religion, okay? So yeah, think about this, okay? If you want to. We'll take 5 minutes break. Okay. Let me grab a beer. Alright, so okay. Yeah, so uh, let me go grab my glasses. Uh, Let me have some beer, okay? Because so basically that's a disproof, okay? So gravitational force, electromagnetic force, field, electric force, magnetic force, wind force, okay? Uh, there is no reason why photon should bend upon gravitational force only when it does not bend in wind force, magnetic force, electric force, because photon, it's not exactly a particle, okay? It's electromagnetic wave, and it's magnetically neutral and electrically neutral, and it does not have any mass. Okay, so photon is more, it's a conceptual model. Okay, it's not a particle, not exactly. Okay, it's not like a baseball. Okay, so there is no rhyme or reason why photon should bend upon gravitational force field when it does not bend in the wind force or electric field or magnetic field. Light photon bends only upon gravitational field. That's wrong. Why? Because light does not have any mass. Okay? So the special treatment of gravitation is wrong. It doesn't not make any physical sense, scientific sense. Okay? Then how about inertial force? This rocket moving up with constant acceleration. Why does the light bend? Parabolic fashion. It doesn't. It looks as if light bend, but it doesn't. Light goes in a straight line. It's because the rocket is accelerating, it looks as if light is bending, like falling to the ground floor of this rocket in a parabolic fashion, but that's the way it looks like, but light does not bend. Not really. It looks as if it bend. Okay? It's only perception. It's not illusion, it's a perception, okay? But light goes straight line. Because rocket is moving up, if the rocket goes up with constant speed, light looks like going down on a straight line, but it doesn't. It goes straight line horizontally, not diagonally. It looks as if light goes down diagonally, but in actuality, it doesn't. It goes straight line horizontally. Okay? We are done. Okay, so cheers. Okay. Yeah, so light does not bend, okay, around gravitation, okay, so nope. Yeah, Mr. Einstein was wrong. Okay, it's that simple. Alright? All these scientists, they were pushed by this ideological wind, this pro Einsteinism. They were pushed around. Okay, so that's why they had to manipulate their data, fudge up their data, okay. I think that's what happened. Okay? Yeah. This is wind blows, right? Just follow the mainstream because their reputation is at stake. So the second experiment, I mean second observation, observatory, this star behind the sun. The second round, scientists they say, oh yeah, still Einstein was wrong, but don't publish it yet because we'll see what happens. It's political, scientific, politics and science. Okay, don't publish it yet. Okay, and they force some data. Okay, yeah, you're right, Einstein, Mr. Einstein, you're a star, celebrity. Okay, let me just go along with you. I think that's what happened. Okay. Okay. Yeah, gravitation have no effect to light, or it does not bend the space. Why? Because there's energy, the first law of thermodynamics. Okay, the conservation of energy, right? Yeah, space and time it should be follow the same rule. Conservation of space and time. Okay, no space can be created. So Mr. Einstein says, yeah, if there's gravitation, the space warp, bend, that's like creation of brand new space, right? I don't think so. Okay. You cannot create a space. Okay. Nothing bends around gravitation, mass, planet, star. No, I don't think so. Okay. We'll take 5 minutes break. I need some vocal rest. Okay. So yeah. So that's the proof. Okay. So gravitational force, it should not get any special treatment. Okay. If light does not bend along the wind force or magnetic field, electric force, then it should not bend in gravitation either. Because photon does not have any mass. Just like it's photon is neutral in terms of electricity and magnetism. Okay, photon doesn't have a north pole, south pole, or it's neither plus positive charged or negative charged. It's perfectly neutral. Okay, because it's not exactly a particle. It's electromagnetic wave energy, right? Uh, so it's wrong to assume that gravitation is so special it bends the light when all the other forces in nature, in the universe, does not bend light. Okay. Let's take 5 minutes break. Okay. So that's your proof. QED. Okay. Yeah. Let's take 5 minutes. Okay. So, do you like this or not? I don't know. I just do my job. Okay. Okay. Yeah, we slay the dragon of this gigantic Einsteinism, right? Uh, well, it's a metaphysical battle, okay? It's nothing physical fight. We don't do that here. Although we study and practice martial arts, but it's for self-discipline, self-defense. We are against violence. We are pacifist, just like Mr. Einstein was, okay? Yeah. Yeah, Mr. Einstein is a very interesting figure, right? He's very handsome, good-looking man. Look like a saint. He looks so right. He looks like Mr. Right, right? Yeah. So it'd be very difficult to say that he was wrong because he looks so right. Looks like Mr. Right. And he's also Jewish, European Jewish, European Jew. Uh, yeah, I mean, we are not anti-Semitic or anything. Okay, we love Jews, right? European Jews, there's Brazilian Jews, and there's orange Jews, apple Jews. I'm just kidding. Okay, come on. We're just making a joke. Okay. Yeah, I have many friends who are Jews. Okay. Have I dated some Jewish ladies? Yes, I have. Okay, they're cool people. Okay, so they're cool. So there's this in his days, Mr. Einstein. There's a Holocaust, right? So Mr. Einstein was kind of a political figure too. I mean, he came to America running away from Nazist Germany, Mr. Hitler, right? Herr Hitler, okay. He ran away, and all this World War II going on. There's this symbol, very symbolic figure, this refugee, right? As a Jewish man, Mr. Einstein ran away from Nazi Germany to America. Okay, so there's this symbolism of peace, science, when all this war going on, World War II, Nazi Germany, this Mr. Herr Hitler. So yeah, he got some political vantage point. Okay, so politics and science, they're not supposed to mix, but they do. Why? Because scientists, they're Homo sapiens too. They're only human. Okay, like Mr. Friedrich Nietzsche said, human or to human, right? We're all human beings, scientists or not. Scientists, they're human too, okay? And human being, we are political, okay? So there's a lot of sympathy going on back in the days of Mr. Einstein. He's a Jewish guy running away from Nazi Germany, running away from Mr. Herr Hitler, coming to America, okay, symbolism of peace. A lot of sympathy toward these European Jews because so many people died there, Holocaust, right? So I guess yeah, it is political wind force. So all the other scientists sympathized with Mr. Einstein. Okay, who came up with all this general special relativity theory when he was a patent clerk? He was not. He didn't belong to academia when he came up with all this special relativity theory. Okay, it's kind of iconic figure. So yeah, let's give him some support, sympathy, compassion. He happened to be a European Jew who had to run away from Germany to America. All this Nazism, Holocaust. Okay, a lot of sympathy, compassion going on. So I guess that's why they fudged their data. to side with this European Jewish man, Mr. Einstein. Okay, I think that's what happened. Because his theory does not make any sense. Science is supposed to be objective, rational, not emotional, not political, not religious. But Mr. Einstein, he was fascinated by this light. Like, yeah, he's German Jewish, right? Yeah, Mr. Jesus, light. Oh, Son of God, Mr. Jesus. Mr. Jesus was Jewish too. I mean, Mr. Albert Einstein, he was not quite religious, okay? He famously said, yeah, God does not roll the dice, right? But he's not quite religious, okay? He was patent clerk in Switzerland, I guess. I don't know, wherever, right? He got his PhD in this Switzerland, very famous school, okay? But I read his biography, okay? He failed once, this college entrance exam, okay? Second time, yeah, he got it, okay? So he was not very good student. He got F, whatever. But somehow he learned tensor calculus, tensor analysis, which is a not very easy thing to learn. All right. You know, in the past 200 lost episodes, yeah, we talked about tensor group theory. I realized past tense. Yeah, I can learn that. I have enough mathematical background to learn tensor calculus, group theory, abstract algebra. Okay, I was kind of surprised because I in the YouTube channel. Okay, yeah, this Google YouTube channel, right? Yeah, they have these free lectures there, and I did study some, and I was able to understand. I was kind of surprised. Okay, so I have enough mathematical background to understand to learn tensor calculus and group theory, abstract algebra. Okay, but I stopped studying that uh, uh, because I want to do my own thing. Okay, like disproving general and special relativity, cyclic sequence, and we have that, right? It helped me to learn those tensor analysis, group theory, abstract algebra. It did help, but I stopped in the middle because it was too inspiring. Okay, so I wanted to go off the tangent, so to speak, for the lack of better words. Okay, yeah, I wanted to do my own thing. Okay, because it was very inspiring. So yeah, I stopped studying that. I wanted to do my own thing. Okay, so okay. Are you convinced about this? Did I persuade you that Mr. Einstein was wrong on both counts, special and general relativity theories? Yeah, I mean he got Nobel Prize for photoelectric effect, and he wrote this nice paper about Brownian motion, statistical study of Brownian motion. Those are right. Okay, so yeah, he got Nobel Prize for photoelectric effect. So this Nobel Prize committee in Sweden, I guess, is it Finland or Greenland or I don't know. The Scandinavia, like you have Switzerland, Finland, Norway. I guess it's Swedish. Okay, Sweden. I don't know. Okay. Nobel Committee. Yeah, they did the right, good job. Oh yeah, relativity. I'm not quite sure. Okay, but yeah, photoelectric effect. Yeah, yeah. I give you a Nobel Prize, Mr. European Jewish Americanized, Mr. Einstein. Okay, Dr. Einstein. Yeah, Professor Einstein. Photoelectric effect. Okay, yeah. Okay, yeah, those are good. Okay, he's a good scientist, but when it comes to special and general relativity, yeah, we just disprove them. I mean, you have your opinion, your belief system. Okay, uh, do what you gotta do, right? I'm just a guy in Alaska. Okay, I don't have PhD. I dropped out of PhD because it was too much. At least, at the very least, Mr. Einstein, he stayed and he got his PhD. But his GPA, I mean, it was grade point average, whatever, right? It was too low to get a professor job, so he got a job as a patent clerk, right? Like 9 to 5 job, low maintenance, right? You got some free time after that, okay? Yeah, 40 hours a week, right? Monday through Friday, 9 to 5, right? But he kept on studying. He's a very good role model. Yeah, he's still my hero. That's what I do. I have 9 to 5, well, 8 to 5 job, 1 hour lunch time, okay? 40 hours a week. I'm a lawyer. Yeah, there's some lawyer mathematicians, right? Like this Fermat and who else? Whatever. There's some doctor mathematicians too. Carnot in Italy, right? Fermat, I guess he was French, okay? Yeah, I have 9 to 5, I mean 8 to 5 job Monday to Friday, okay? But in my spare time, I study mathematics and physics, humanology, linguistics, whatnot. Okay, so yeah. I also have patent license. Okay, I'm a patent attorney on paper. I used to be patent agent, but as soon as I got my lawyer's license, because I studied for bar exam, I passed. Second time, first time I missed by 1 point. Alaska bar exam. Okay, it's a high bar. Okay, I don't know why, but they have 280. Okay, high bar. My score was 279. Okay, I missed by 1 point at the first time. Second time I passed with some comfortable margin because my friends they helped me. Okay. Yeah. So I'm a patent attorney on paper because I don't practice patent. Okay. They call it patent prosecution. I don't know why they name it that way. In the U.S. Army, they call themselves JAG, Judge Advocate General. I don't know how they came up with those names. Okay, legalese. Yeah, they're strange people, right? Lawyers, right? Strange people. I'm a lawyer, okay? I got lawyer's license, right? Uh, but if I convinced you or not, I leave it up to you, okay? If you want to think Mr. Einstein was right about this relativity, special and general, well, that's your freedom. I respect that. I love U.S. Constitution. Okay. Yeah, freedom of speech, freedom of thought, freedom of ideas, ideologies. Okay? Yeah, I love American freedom. That's why I came here. I used to have dual citizenship, Korean, American. I chose America when I was like 18. Okay, because I wanted to be free. Okay, yeah, South Korea, fantastic country. Okay, but not as much freedom as in America. Okay, so you buy this SHIT, you buy this, or you wanna go along with mainstream majoritarian, Mr. Einstein. I leave that up to you. Okay, I did my best. Okay, yeah, I respect your rights, your freedom, no matter what country you are at now. Okay, you may be in Syria or Afghanistan or India, China, Korea, Japan, Taiwan. You may be in Europe, or you may be in Florida, Louisiana, Hawaii, or you may be in Alaska. Okay, I don't know who you are. Okay, and I wanted to keep it that way, remain anonymous, because this humanology is very controversial topic. Okay, so this particular brand of humanology. Okay, so I don't want any harm coming to you. So yeah, we'll take 5 minutes break. Okay. Yeah. It's kind of informal proof, right? Yeah. Uh, Basically, yeah, the photon does not have any mass. It's not polarized. It's not negative charged, positively charged. It's not north pole, south pole. It's neutral, light, photon. Okay. This hypothetical particle, photon, right? It has no mass, no electricity, no magneticity. Okay, no weight, no mass. So wind force, electric force, magnetic force, gravitational force. It's not gonna affect this photon's trajectory. Okay, it goes straight. Okay. Oh, inertial force, acceleration, accelerated rocket. Yeah, it does not bend the photon's trajectory. Okay, it goes straight line, but because you are moving up, it looks as if it's gonna bend if you have acceleration, parabolic trajectory. Of if but if you are constant velocity, yeah, diagonal, straight line. Okay, but photon it goes straight. It's your perception. Okay, so that is where Mr. Einstein erred in his thought experiment. At least that's what I think. Okay, whether you agree with me or not, that's up to you. I respect your freedom of thought, ideas. Okay, you wanna go along with the mainstream majoritarian view, well, that's your problem. Okay, it's up to you. Okay, you do whatever you gotta do. Okay, so we take 5 minutes break. Okay, all right. Alright, we're back. As you can see, yeah, I'm drunk. Yeah, let's put this whiteboard behind us, alright? We just talk. You have like 20 minutes left, right? Okay. Yeah, but no worries. I don't drink and drive. I'm not driving. What time is it? 11 o'clock. Saturday. The last day. We have leap year 2020, right? Yeah, it's last day in February. 229, right? Yeah. Okay. Cheers to that. Okay. Yeah, I think about this movie, Amadeus. Oh, Mozart. Da. Mozart. Da. Dun, da, da, la, 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 da, da, la, da, da. Da, 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 la, 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 dun 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 dun. Yeah, the Wolfgang Amadeus Mozart, Mr. Signore Salieri. I love that movie. I have DVD. Maybe that's what we're gonna watch after this recording. We have 50 minutes left. Okay. So Mr. Salieri, okay, it's all fiction, right? Yeah, it's British play, right? Mostly fictional, okay. Mr. Salieri is cool, okay. He didn't murder Mozart, okay. No. So fictionalized, so made up story. But based on true story, okay. So yeah, Mozart and Salieri, right? This X-File episode about that, okay. Magicians, musicians, mathematicians, right? Yeah, it's cool, right? So this proof of general relativity theory is kind of informal, okay? So yeah, no special treatment for gravitational force. That's general relativity disproof, and no special treatment for light. Oh, Mr. Jesus, the Jewish Hebraism, and Mr. Albert Einstein, the European Jewish scientist. Okay. Yeah. Special treatment, whatever. Okay. Yeah, I'm kind of conservative in that sense. No special treatment, right? Yeah. I'm kind of conservative. No special treatment for this German Jewish man, Mr. Albert Einstein. Okay. No sympathy because we are doing science. Okay. Science and politics, religion, it's not supposed to mix. Okay. We are doing science. Okay. But that's what they did. Mixing science, politics, religion, light, absolute. Oh, absolutivity. Jesus. Son of God, Jewish, Mr. Albert Einstein, German Jewish, European Jewish. Light, absolute, sympathy, Holocaust. They're missing it all together, like science, religion, politics. Come on. So we are correcting the error. Okay? I do my best. Okay? This is what I can tell you. Alright? What can I what can I tell you? Okay, I'm sorry if I disappointed you. Okay, for disproving Mr. Einstein's theory, general and special relativities. I'm sorry. I apologize. But I had to do it. Why? Because he was wrong, as far as I can tell. I could be wrong too. I do not exclude that possibility. Let me just grab a beer, okay? You may have spent your lifetime defending as a scientist. You're defending Mr. Einstein, right? Are you a lawyer? I mean, why are you defending Mr. Einstein? Are you a lawyer? I thought you are a scientist. Am I a lawyer? Yeah. Am I a scientist? Well, I had to drop out this PhD, okay? But I'm an amateur scientist, okay? So I just disproved him. Disproved him. I'm just a small guy in Alaska, of all places. Before Alaska, I was in Michigan, law school. Ann Arbor, Ypsilanti, Detroit, Michigan, okay? I've been to Grand Rapids, okay? Fantastic town, okay? I've been to some other towns in the Midwest. Before that, I was in the U.S. Army, Fort Hood, Texas. Before that, yeah, Afghanistan. Before that, yes, Georgia. Before that, I was in San Jose, California. Before that, I was in Los Angeles, California. Before that, I was in Ithaca, New York. Alright. Before that, I was in Madison, Wisconsin. Okay. Before that, I was in Seoul, South Korea. Yeah, I was in Vancouver, Canada. Okay, because it was a family reunion there. Whistler, ski. I tried to learn this snowboarding. All right. It looks so cool, right? Like sideway, like this. Okay, snowboard. But I wasn't very good at it. Okay, so they had to because I fell. Whistler, Canada. Okay, they call this snow machine, this whatever scooter. Okay, I was ashamed. All right, I couldn't do this snowboarding, so they call this snow machine. Okay, so I was like, I can ski. Okay, yeah, but snowboarding, it was too difficult. Okay, okay. So we wrap this up episode, okay? Yeah, I disproved to you general special relativity, okay? Yeah, Mr. Einstein, I'm a huge fan still, alright? But he was right in photoelectric effect. His statistical study of Brownian motion, that's what got him Nobel Prize. Sweden, I guess. But when it comes to special and general relativity, I just disproved. Okay, whether you accept this proof or not, I'll leave that to you. Okay, at least legally, I'm American citizen. Some people don't think I'm American citizen. That's fine. Okay, I disproved Einsteinian general and special relativity theories to you. Whether you approve this disproof or not, I'll leave that to you because I respect your freedom. No matter what country you're at, you may be in Afghanistan, India, China, Korea, Taiwan, Japan, or you may be in Switzerland, Germany, France, or Sweden, Finland, Norway, Canada, America. Okay, it's up to you because I respect your freedom of ideas, of thought, ideologies. Okay, I did my best, my very best. Okay, but at the same time, I respect your very best effort, your idea, your freedom, your liberty, your property. You decide. This Alaskan aging Asian, so-called American ASSHOLE. Okay, I cannot pronounce that because people are watching me. Okay, so I have to watch my mouth. Right. Alaskan aging, so-called American Asian aging ASSHOLE. Okay. You decide, okay? You side with me, you side with Mr. Albert, the great German European Jewish man. It's your choice, okay? You're entitled to your own opinions. I'm just a small guy. I don't even have PhD. I'm just Asian Alaskan guy. I'm not asking. I'm not asking to join me on this. What I'm asking is that you be an independent thinker. Have some backbone. Okay? Prove me wrong. Or if you want to, yeah, join the Mr. Einstein Club, like the rest of the world do. Yeah, join the herd, be majoritarian mainstream, or try something new. Join me, or come up with your own theory. Be free, be peaceful. Okay? Yeah, learn martial art, defend yourself, self discipline. Learn dancing, be peaceful, be happy. That I'm asking. Be peaceful, be happy, be beautiful. Okay, is it too much to ask? I'll leave that to you, okay? So thank you. I'm sleepy. I gotta go to bed. All right. So thank you. Good night. Bye.